Okay, this is the third lesson of our lesson series. Now we have started quadratic equations and functions, and we have explained what is the behavior of a quadratic equation and a function, and we have done some exercises. Right now, I am going to write down the standard notation of a quadratic equation, right? So standard notation, we have done this in last week. Fx equal to ax square plus bx plus c. This is the standard notation of a quadratic equation. So in here, simple a comma b comma c are real numbers. Those are real numbers, right? And simple a should not be equal to 0, right? So this is a quadratic equation. Now we have done some analysis of this equation in our previous 2 lessons, right? Now in this lesson, I am going to explain about this equation using this equation, right? Now before that, I am going to just give a small reminder about the last 2 lessons. So in the previous 2 lessons, we have identified some basic characteristics of quadratic equations, right? So I'm going to explain those 2. I'm going to explain those characteristics quickly. So if you consider this quadratic equation, here we have x square term, x term, and a constant term, right? So in this quadratic equation, if you consider the coefficient of x square term, it is simple a, right? So if simple a is greater than 0, that means if the coefficient of the x square term is a positive number, is a positive integer or a positive number, then we will have a minimum value. So the shape of the quadratic function is this, right? When the coefficient of x square is greater than 0, right? Next, if the coefficient of the x square term is less than 0, that means if it is a negative number, then the quadratic function have maximum value. The quadratic function has a maximum value, right? So those are the things we explained previous week, right? And also if you consider the quadratic equation, when you simplify this equation using the completing the square method, when you simplify this equation using the completing square method, if this is a complete square, right? When we simplify fx, that means the quadratic equation, fx quadratic equation using completing the squares, first one we can have is a complete square, right? If you simplify this, there can be a different result. First result is we can have a complete square when we simplify this using the completing square method, right? So if this is a complete square, if you get a complete square, when you simplify this quadratic function, if you get a complete square, that means the function will touch the x-axis only at one point, right? It will touch the x-axis only at one point, like this, or like this, with the minimum or maximum. That means you have one solution. Right? Secondly, when you simplify this using the completing square method, if this has 2 factors, or if this can be separated into two factors using difference of two squares, then can be separated into two factors. Then the graph or the function will intersect x-axis. Then this will intersect x-axis like this with a minimum or a maximum, right? So if this graph can be, if this quadratic equation can be separated into two factors, then we can have, then this function will have two intersection points, right? 2 points which intersect with the x-axis. If this is a complete square, you have 1 point, right? Then thirdly, next, if you simplify this quadratic function, using the completing square, if you get no factors, or if there are no factors, that means you will get sum of two squares, right? Right? If you have no factors, when you simplify this using the completing the square method, then the graph will look like this. So this is the x-axis. The graph can be situated above the x-axis or below the x-axis without touching it. That means there are no factors, right? No factors means this can be a sum of two squares. Sum of two squares. If this is a sum of two squares, then this function will have no factors. So if this can be separated into two factors, that means this function is a difference of two squares, right? So these are the three results you will get when you use the completing square method to simplify fx function, right? There can be a complete square. That means there is a 1 point, one solution of touching x-axis, right? There can be two factors. That means the function will intersect x-axis at 2 points. That means two solutions. Or the function has no factors. That means there are no solutions, or the function will not touch the x-axis, right? So these are the things we have discussed in the previous two lessons. Now I'm going to use our standard quadratic function to derive some basic results, right? Now look at this. Right. So I will take the quadratic function fx equal to ax square plus bx plus c. Right. So here a, b, c are real constants, and a is not equal to 0. Right. Now this is the standard notation of a quadratic function. Now I am going to use the completing square method to simplify this quadratic function. Right. Now here the first step of simplifying a quadratic function is you have to have a positive 1 as the coefficient of the x square term, right? So here the coefficient of x square term is simple a, not positive 1. So I'm going to separate simple a, then brackets, this will be x square plus b over ax plus c over a, right? Now here the coefficient is positive 1. Now it's okay. Now if you multiply by a, you will have ax square plus bx plus c. Now I'm going to use the completing square method to simplify this, right? So here simple a. Now take x square without the square, then x. If there is a positive sign, take the positive sign. Divide the coefficient of x by 2, then b over 2a. take the square of the whole thing negative minus square of this constant. That means b square over 4a square plus c over a plus c over a. Now I am going to simplify this. So here we have fx equal to simple a x plus b over 2a whole thing square. Now I'm going to multiply this factor, this term by 4a from in the numerator and denominator. Now I will have minus b square over 4a square. If you multiply numerator and denominator by 4a, then 4ac. Here we have 4a square. Now we have a common denominator. Now I'm going to simplify this. Fx equal to a into x plus b over 2a whole thing square minus. So I'm going to take the minus sign. I'm going to separate the minus sign from these two terms. Now minus b square minus 4ac over 4a square. Right. Now in this way we can separate this into two terms. Here we have is complete square minus. Now this one also can be written as a complete square. Right. This part also can be written as a complete square. Then we can simplify this. Right. So right, then you can factorize this. If you can write down this part as a complete square, you can factorize this. Right. So this is the standard formula. This is the standard notation of a quadratic equation. We have started from this one. Then I have separated simple a, then brackets x square b over ax plus c over a. Then I have used the computing square method to simplify this. Now I have simplified up to this. Right, I have simplified up to this. Now I'm going to write down this final result. So here we have right, here we have fx equal to a into x plus b over 2a whole thing square minus b square minus 4ac over 4a square. Right. Now we have this. Right. Now look at this one. Right. So if you consider this part in here, if you consider this b square minus 4ac part, right? If you consider this part, if you take the square root of that, if you take the square root of this whole thing, then you can write these two as difference of two squares, right? You can write these two as difference of two squares. Then you can factorize this, right? So I'm going to write down like that. Fx equal to simple a into x plus b over 2a whole thing square. I'm going to take the square root of this minus b square minus 4ac square root over 2a whole thing square. Right. If you square this, you will get b square minus 4ac. If you square 2a, you will get 4a square. Right. Now here we have difference of two squares. Right. Difference of two squares like a square minus b square. So x square minus b square equal to a minus b into a plus b. Right. That means if you have difference of two squares, you can write down this into, you can separate this into two factors. Now this can be separated into two factors. Right. So that's our aim. That's our target. But here we have a problem. Here we have b square minus 4ac inside the square root sign. Right. Now we don't know this b square minus 4ac is a positive value, 0 or negative value. Right. If this is a positive value, then it's okay. This can be separated into two factors. Right. But if b square minus 4ac is a negative value, then you will get a negative square root here. Then you cannot separate this into two factors. That means there are no real solutions if b square minus 4ac is a negative number, right? So according to this b square minus 4ac, this function can be separated into factors, or this function cannot be separated into factors using b square minus 4ac. We can tell that, right? Now firstly I'm going to write what will happen if b square minus 4ac, if b square minus 4ac greater than 0. If b square minus 4ac greater than 0, what will be? Right. So now look at this. Now look at this. Right. Now look at this. So if b square minus 4ac is greater than 0, that means inside this square root we will have positive value. If this is a positive value, then this can be written as a complete square. Then you can separate this into two factors. Then you can separate this into two factors. Right? Can be separate into two factors. Alright, two factors by using the difference of two squares. If b square minus 4ac is greater than 0, this can be separated into two factors by using the difference of two squares. That means there are two factors. That means this function will intersect the x-axis. That means this function will intersect the x-axis. Then this can be written down as, this function can be drawn as this. Right? There are two intersection points here. Here also we have two intersection points. If b square minus 4ac is greater than 0. Right. Now let's see what will happen if b square minus 4ac is equal to 0. Right, this is the first one. Then write down second part. Write down second part. If b square minus 4ac is equal to 0, what will happen? Right, equal to 0. Right. Now look at this. If b square minus 4ac is equal to 0, this whole part will be equal to 0. Then this term will cancel. Right. Then there is only one complete square. That means you have a complete square as the answer. Right. Right. You have a complete square. Right, has a complete square. That means there is only one solution. If you have a complete square, you have only one solution. That means the graph can be drawn like this or like this. Right. So if b square minus 4ac, there is only one solution, one place that the graph will touch the x-axis. Right. Now look at this. What will happen if b square minus 4ac is less than 0? Right. Third part, look at this. If b square minus 4ac less than 0. Right. So if b square minus 4ac less than 0, then this square root will become, then inside this square root you have a negative value. So negative square roots are not varied in here. So if there is a negative square root, that means there are no real solutions, right? So that means you cannot separate this into two factors. You cannot separate this into two factors. Right. That means there are no factors. There are no factors, no real solutions. So you can draw the graph like this. You can draw the graph above the x-axis without touching it, or below the x-axis without touching it. Right. So this is the nature of the graph when there are no factors. That means b square minus 4ac less than 0. Right. Now we have derived three results using this. Right. So right. Now this b square minus 4ac is known as the determinant or delta. Right. B square minus 4ac is known as the determinant or delta. We can write down b square minus 4ac. Right. So using this delta value, we can find out this function can be separated into factors, or is a complete square, or cannot be separated into factors. That we can determine using this delta value. Right. Now I'm going to write down a small summary about the part we have done. Now look at this. I'm going to take the quadratic function fx equal to ax square plus bx plus c. Right. So right. So delta, that means the determinant. Write down determinant delta equal to b square minus 4ac. Here delta determinant equal to b square minus 4c. So if you consider this function, b square means square of the coefficient of x. Square the coefficient of x minus 4 times coefficient of x square term into constant. Right. So I will tell that again. Delta equal to square of the coefficient of x minus 4 into coefficient of x square into constant term. Right. From that you can find the determinant or delta value. Right. Then if delta is part 1, if delta is greater than 0, if delta is greater than 0, right, if delta is greater than 0, the function will intersect the x-axis. Right. When delta is greater than 0, the function will intersect the x-axis. Secondly, if delta is equal to 0, then the function will touch the x-axis. Then the function will touch the x-axis. Right? The function will touch the x-axis. Thirdly, when delta is less than 0, the function will not touch the x-axis. Right? When delta is less than 0, the function will not touch the x-axis. Right? That means the function will lie above or below the x-axis. Right. So this is the final result we can derive using this b square minus 4ac. That means the determinant. Right. Okay. Now let's do a simple problem. Right. So now I'm going to erase this. Okay. Now look at this. Right. So I'm going to take two factors. I look at this one, x plus y minus 1 into, I'm going to take two factors, plus y minus 1 into 2x minus y plus 2. 2x minus y plus 2. Right. Now, this is a linear factor. Right. This is a linear factor. Right. These are two linear factors. These are two linear factors. I'm going to multiply these two linear factors. Now look at this. Linear means the power of x, maximum power of x is 1, maximum power of y is also 1. Here also maximum power of x is 1 and maximum power of y is also 1. Right. Now, if you multiply these two linear factors, you will get a result. Right. So x into 2x, you will get 2x square. Right. X into minus y minus xy, x into plus 2 plus 2x. Y into 2x plus 2xy, y into minus y minus y square, y into plus 2 plus 2y. Then minus 1 into 2x minus 2x, minus 1 into minus y plus y, minus 1 into plus 2 minus 2. Right. Then here minus 2x and plus 2x will cancel. Then the answer is we have 2x square minus y square. Here we have minus xy plus 2xy. From that we can write down plus xy plus xy. Here we have 2y plus y plus 3y minus. Right. So when you multiply these two factors, x plus y minus 1 into 2x minus y plus 2, you will get the answer as this. Right. You will get the answer as 2x square minus y square plus xy plus 3y minus 2. Right. Now, if you look at this one, here we have x square term, y square term, xy term, y term, and a constant term. Right. Now, there are two variables here. Right. There are two variables here. So, first variable is x, second one is y. So, we can denote this function as fx comma y. Right. Fxy means function of x and y. Right. Fx means function of only x. Right. So this is the notation fxy. Right. So this is the product of two linear factors. This is the product of two linear factors. From this product, you will get fxy. Fxy means fxy is a function of two variables. Right. Now, look at this. We have simplified these brackets. Then we have got this function. Right. We have simplified these brackets. Then we have got this function. If you multiply this, you will get this. Now, we can do the reverse of that. From using this function, we can find the linear factors of this function, right? Using this function, we can find the linear factors of that function, right? So, to do that, we use the completing square method, right? We use completing the square method, right? Now, let's see how we can do that. Let's see that. Now, I'm going to write that x comma y, that's equal to 2x square minus y plus xy plus 3y minus 2. Right? Y square. Right. Now, Now look at this. So here we have two linear factors. Right? Here we have two linear factors. Now we are going to multiply. We are going to simplify this using the complete square method. Right? We are going to simplify this using the complete square method. So basically, this one has two variables. Here we have two variables, right? But we can express this as a quadratic function of x or y, right? So look at this one. Here we have x square term. Here we have x term and a constant term. Here we have y square term. Here we have y terms and a constant term, right? So if you think about it, if you assume x is a constant, then you can write this function as a quadratic equation of y, right? Also, if you assume y is a constant, then you can write down this as a quadratic equation of x. But in reality, this is not. In reality, x is not a variable. X is not a constant. X is a variable. Y is also a variable. But for the simplification purpose, we assume that x is a constant. Right? If you assume, then you can write down easily this as a function of quadratic function of y. So I will write down minus y square plus here we have y, here also we have y. So if you take out y, here we have x plus 3 into y. Right? Then we have plus 2x square minus right, plus 2x square minus 2. Right. Now, if you think about it, this is a quadratic equation of y. Right? This is a quadratic equation of y. Here we have y square term. Now look at this. Here we have y square term. Here we have y term. Here this is a constant term. We have assumed x as a constant, right? Now this is a quadratic function of y. This is a quadratic function of y. Now, if this is a quadratic function, you can use the completing square method to simplify, right? You can use the completing square method to simplify, right? Now look at this. I am taking out minus sign out of this. If you take minus sign out, we have y square minus x plus 3 into y minus 2x square plus 2. Right? I have taken out minus sign out of the brackets. Then if you multiply by minus, you will get the same function. Right. Now, next step, we can use the completing square method. Minus, right, here we have y square. Take the y square term without square mark. Without the square, then y. If there is minus sign, negative sign, write the negative sign. If there is a positive sign, write the positive sign. Then divide the coefficient of y term by 2. Divide the coefficient of y term by 2, then x plus 3 over 2. Right? Then take the square of the whole thing. Take the square of the whole thing. Square. Right? Then a negative, write the square of this constant x plus 3 square over 4. Right? Then the remaining parts are minus 2x square plus 2. Now we have done the completing square step. Now we have to simplify this. Then we can separate this into two factors. So it's a simple problem. You just have to imagine this as a quadratic function of y, or you can imagine this as a quadratic function of x. But in reality, you have both variables. Right. Now let's simplify this. Here we have denominator is 1. Here also denominator is 1. Right. Then this is equal to minus y minus x plus 3 over 2 square of the whole thing. Square of the whole thing minus, if you take the common denominator, you will have x plus 3 square. Here plus multiply by 4, that means 8x square. If you multiply by 4, 8 over 4. Right? Now 4 is the common denominator. Right. Now we can simplify this. Then now look at this. Look at this. Right. So here we have fx comma y. Fx comma y equal to minus. Here we have y minus x plus 3 over 2. Square of the whole thing minus we have x plus 3 square. Now you can expand this. If you expand this, x square plus 6x plus 3 square means 9 plus remaining part 8x square minus 8 over 4. Right. Now we can simplify this. Now look at this. Right. So here we have x square plus 8x square, that means 9x square. Right. So I can write down fx comma y equal to minus. Here we have y x plus 3 over 2 square of the whole thing minus x square plus 8x square, that means 9x square. Here we have 6x plus 6x. 9 minus 8 means plus 1 over 4. Right. So 9x square plus 6x plus 1. So we can write down that as a complete square. Right. We can write down this part as a complete square. Then we can write down fx comma y equal to minus y minus x plus 3 over 2 square of the whole thing minus 9x square plus 6x plus 1. That part we can write down as 3x plus 1. 3x plus 1. Square of 3x plus 1. Right? The square of 3x plus 1. So if you take this square, 3x square means 9x square plus 2 into 3x into 1, that means 6x plus 1 square means 1. 4 we can write down as 2 square. So we can write down this whole part as a complete square. Right? We can write down this as a square. Now we can separate this into two factors. Right? So look at this fx comma y. This is equal to minus first factor y minus x plus 3 over 2 minus 3x plus 1 over 2. First factor into second factor y minus x plus 3 over 2 plus 3x plus 1 over 2. Right. Now let's simplify these two factors. Fx comma y equal to minus. Right. Look at this minus. We have minus x minus 3 minus 3x plus 1. So minus x minus 3x means minus 4x. Right. Here minus 3 minus 1 means minus 4. Right. If you divide by 2, y minus 4x divided by 2 means minus 2x. Right. Minus 4 divided by 2 means minus. Right. Then second factor y minus x here plus 3x. Minus x plus 3x means plus 2x divided by 2, that means plus x. Here we have minus 3. Here we have plus 1, that means minus 2 divided by 2 minus. Right. Now we got the two factors. Now we can multiply this first factor by the minus sign. Right here we have a minus negative sign. You can multiply this negative sign with the first factor. Then you will get x comma y, that is equal to, if you multiply this one, the y become negative, this one become positive, and this one become positive. So 2x minus y plus 2 into x plus y minus 1, right? So here we got the two initial factors, right? So these are the two factors we have used to develop this function. Now using this completing score method, we have again found these two factors, right? So this is a very simple method you can use to find the, you can use to factorize the quadratic equations with one variable or two variables, right? Okay, right. Now let's go to the next part, right? Okay. Now this part is over. Let's go to the, let's do some simple problem, then we can go to the next theory part. Right, before going to the theory part, let's do a simple problem. Right. Okay. Right. So write down. Right. Write down a small problem. Write down. Solve the following equations. Solve the following equations. Solve the following equations and find the value of x. Solve the following equations and find the value of x. Right. First part. So look at this. I will get an equation 2x square minus 7x plus 6 equal to 0, right? When this part is equal to 0, that is the equation. When this is equal to fx, that means that is a function. So we will discuss the difference between equation and a function deeply in the next section, right? We will discuss the difference of a equation and a function deeply in the next section. But before that, we have to do these questions, right? First, we can do this question. Then after that, I will tell the difference between the equations and the functions. So now this is a equation. This is equal to 0, right? There is only one variable x. X is the variable, right? Now here we have 2x square minus 7x plus 6. X square term, x term, and the constant term, right? So now you can find the value of delta. You know that delta equal to b square minus 4ac. B square, b means the coefficient of x. Coefficient of x is minus 7. So b square means minus 7 square minus 4ac. 4 into a means the coefficient of x square term 2, c means 6, right? So if you write down the answer, delta equal to, here we have 49 minus 4 into 2 into 6, that means 48. So here delta equal to 1, that means greater than 0. Value of delta is greater than 0. That means it has two real roots. Therefore, has two real roots according to our previous observation. Right? This function has two real roots. So if this has two real roots, we can find the roots by using completing the square method. Right? We can find the roots using the completing square method. Right. Now look at this. Look at this one. Here we have 2x square minus 7x plus 6. So this equation is in the standard format. First x square term, next x term, next constant term, right? But the coefficient of x square term is not positive 1. So I'm going to divide both sides by 2. Then this will become x square minus 7 over 2x plus 3 equal to 0, right? I have divided this whole equation by 2. Now we can use the completing square method. Take the x without the square, x minus, take the coefficient of x square and divide it by 2. That means 7 over 4. Take the square of whole thing minus square of this constant. 49. 7 square means 49 over 60. Plus the remaining part. Remaining part is 3. Right. Now look at this. Here we have x minus 7 over 4 square whole thing minus 49 over 16 plus if you multiply both numerator and denominator by 16, right? If you multiply both numerator and denominator by 16, this will become 16. 16 into 3 means 48 equals, right? Now minus 49 plus 48 square minus 49 plus 48, that is minus 1 over 16 equals 0, right? Equals 0. Now we can separate this into factors. Now look at this. I'm going to write down this part. X minus 7 over 4 square of the whole thing minus 1 over 16. I can write down as 1 over 4 square. Now we can separate this into two factors. We can separate this into two factors by difference of two squares. Right? First factor x minus 7 over 4 minus 1 over 4 into x minus 7 over 4 plus 1 over equal to 0. Right? Then we can write down as x minus, here we have minus 7 minus 1, that means minus 8 divided by 4 means 2. Here we have minus 7 plus 1, that means minus 6 divided by 4. 6 divided by 4, that means 3 over 2 equals 0. Right? So then we can separately equal these two factors into 0. That means x equal to 2 or x equal to 3 over 2. There are two solutions or two roots for this equation. Right. Okay. Now write down this. After that, let's do another simple question. Right. Then okay. Let's do another question. Right. Then write down second question. Here also you have to find the roots of this equation or the x value. Right. So write down 4 over x plus 4. First term minus 3 over x plus 3 equal to 2 over x plus 2 minus 1 over x plus 1. Right. So this is the equation, and here they have given that x is not equal to minus 1 comma minus 2 comma minus 3 comma minus 4. They have given that x is not equal to minus 1, minus 2, minus 3 or minus 4. Right. Now we have to simplify this and find the values of x. Right. So I'm going to take the common denominator of these two separately and common denominator of these two separately. Right. So here we have common denominator is x plus 4 into x plus 2. Right. Here we can write down 4 into x plus 2 minus 3 into x plus 2. That is equal to, here common denominator is x plus 2 into x plus 1. Here we have 2 into x plus 1 minus 1 into x plus 2. Right. Okay. Now we can simplify the brackets. Then we have 4x plus 4 into 3, 12 minus 3x minus 12 over x plus 4 into x plus 3. That is equal to, here we have 2x plus 2 minus x minus 2 over x plus 2 into x plus 1. Right. Now, if you simplify this, here 12 and minus 12 will cancel. Here also 2 and minus 2 will cancel. Right. Then 4x minus 3x, that is x over x plus 4 into x plus 3. That is equal to 2x minus x, that is x over x plus 2 into x plus 1. Right. Now, here you cannot simplify x and x. You cannot cancel x and x, because if you cancel, you will reduce one answer. Therefore, you have to cross multiply this. Then you have to simplify. Right. Okay. Now I'm going to cross multiply and simplify this question. Right. So if you cross multiply this, x plus 2 into x plus 1 into x, then we can write down x into x plus 2 into x plus 1. That is equal to, here also we can cross multiply, x into x plus 4 into x plus 3. Right. X plus 4 into x plus 3. Right. Then we can separate, here we have x is common. We can separate x. Here we have x plus 2 into x plus 1 minus, right, right. Before that, I'm going to take this whole section to this side. Then x into x plus 2 x plus 1. I'm going to take this whole part to this side. Then minus x into x plus 4 into x plus equal to 0. Then we can separate x. If you separate x, then brackets x plus 2 into x plus 1 minus, here we have x plus 4 into x plus 3 equal to 0. Right. Now we can simplify. Right. So if you simplify the brackets, x plus 2 into x plus 1. Here we have x square. Right. X square. Here we have x into 2 x plus 2x, that means 3x plus 2 minus second part x square plus 3x plus 4x plus 7x plus 2x equal to 0. Right. So here x square and x square will cancel. Then we have x into, here we have 3x minus 7x, that means minus 4x. Then we have plus 2 minus 12 minus 3 equal to 0. Right. So if you separate, if you take minus 2x, if you take minus 2 out of this, then minus 2x into 2x plus 5 equal to 0. Right. So now you can divide by minus 2, x into 2x plus 5 equals 0. So this is the final result. Now you can separately equal these two parts into 0. Then x will be equal to 0. 2x plus 5 will be equal to 0. Then here x equal to minus 5 over 2. So there are two answers, x equal to 0, x equal to minus 5 over 2. Right. So that is the solution of this equation. Okay. Now, before going to the next part, let's do another simple equation. Right. I think now you can simplify this using the completing score method. We have done 2 questions. Now I think you have understood the method, but there is another section in this quadratic equations, right? So okay, right. So in the next video, we will discuss about the next part of the quadratic equations. Then we can go to the basic inequalities, and then we can go to the remainder theorem and factor theorem, right? So in this video, we have discussed about the quadratic equations, and we have done some small basic problems, right? So there is another part of the quadratic equations. In the next videos, we are going to do the next part of the quadratic equations. After that, we are going to go to the remainder theorem, factor theorem, and basic inequalities, right? Okay, that's it for this video. Thank you.